Okay, 7.8, graphing functions. Everybody should be on page 354 to 355. All right, in example 1, what you see here is much like what you saw yesterday in 7.7. We're doing an input-output table by substituting my domain values into my function. So that's where I'm starting. I do y equals -2 plus 4, y equals 0 plus 4, and y equals 2 plus 4. All right, and I evaluate, and my output is 2, 4, and 6. 2, 4, and 6. All right, now, what I'm going to do with this now, yesterday this is where I stopped. But now I want to show you that we can actually take our domain and our range, what we put into the function and what we took out of it, and we can make an ordered pair out of it. -2, 2. My second ordered pair would be 0, 4. Make sure you're writing this down. And my third ordered pair will be 2, 6. Now I can take these ordered pairs and I can graph them. So notice in the top left-hand corner, I have -2, 2, 0, 4, and 2 and 6, and then I graphed it. Yes, this is on your homework. So, and this is example 1. Example 1.
I know this right now. Do you want us to graph it?
Yeah, I want you to go ahead and sketch the graph. Okay, you don't have to fill in every single part of it, but I do want you to sketch this graph in your notes. All right, just make sure you sketch this in your notes. All right, and we can come back to it as well.
What's it called with the arrow again?
Okay, well that's just my line. I'm showing that this is a linear function, and make sure that you label the function on the graph. All right, now remember, we can come back to this. All right, so don't worry if you don't get it all written down. Okay? All right, now let's move on to example 2. In example 2, the only difference here is I'm looking at the difference or the relationship between my input and output values, and I'm trying to figure out what my function rule is going to be. All right, so obviously my numbers are increasing from the input to the output. What do you think my function rule is going to be, Jared?
Multiply by 2.
Very good. And how would I write that function rule?
Y equals x times 2.
Or 2x. 2x. Okay, x times 2, but we would write that 2x. Okay, y equals 2x. Now I can take these sets of numbers, and they're basically my ordered pairs. So I have 0, 0, 1, 2, 2, 4, 3, 6, and 4, 8. All right, and I can take these ordered pairs, and now I can graph them. Remember, it's okay if you don't get the graph written down because we'll come back to it. Okay, and this is example 2. Example 2. All right, so notice that I basically plotted a point for each one of these coordinates, 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, and even went up to 5, 10. Drew my arrow straight through and wrote my function, y equals 2x. Y equals 2x. And that's how you do example 2. That's all there is to it. So figure out the relationship between the input and output, write your function rule, and then plot those points on your coordinate graph.
On the homework, it's going to be like big numbers, like 5, 2.
We're about to talk about your homework right now. Okay. On your homework, you're going to see something very much like this function. It's just going to say graph the function, y equals 10 minus x. But there's something that they leave out here that they normally give us.
The table.
The x values. They don't give us any x values. They just say graph the function. So we're going to come up with our own x values. And the ones I want you to use on your homework and on your quiz and test are going to be the basic -2, -1, 0, 1, and 2. Those are the numbers I want you to use on your homework tonight. So when you do numbers 6, 10, 12, and 14, That's the domain I want you to use. Okay? It's just a very standard one, but it shows the line on both sides of the 0, both negative and positive. All right, so now let's do a couple substitutions until we can figure out the pattern. Y equals 10 minus negative 2. Why do I have two negatives here? Why not just one negative? Why do you think? I have to keep the negative that was already in the function. Okay, so the negative that was already in the function stays there, but then the domain I'm inputting is negative 2. So it's a double negative. And guys, that's important because now I'm adding, and now this is going to be 12. No, I'm adding. The only reason I have parentheses there is to separate my double negative. Okay? All right, so that's my first substitution. Now let's do another one. Y equals 10 minus negative 1, which is 10 plus 1, which is 11. So that's my second output. All right, now let's do another one. Y equals 10 minus 0, which equals 10. Okay, does anybody see a pattern now with the y's? 12, 11, 10. What's my next two numbers? 9 and 8. So I don't even have to do the substitutions for those. So I just want to see you substitute the first couple, and then once you pick up on the pattern, you can just fill it in. All right? And remember, you can use your calculators on this as well. Okay? All right, now that I have my x and my y values, these are my ordered pairs, and now I can come over and I can graph it. All right, I'm going to graph these ordered pairs, x and y, and I've just rewritten the ordered pairs so you can see them on the graph as well. So my first coordinates are negative 2, positive 12, so that's where I plotted my point. Then I go left 1, up 11, over 0, up 10, right 1, up 9, right 2, up 8. And then I draw my line through, my arrows on both ends of the line, and I graph my function y equals 10 minus x. And that's how I would graph it. All right, so on your homework, they don't give you the domain. So what domain do you use? Yeah, the same domain, negative 2, negative 1, 0, 1, and 2. That's the domain I want you to use. From negative down to the positive. Yes, we go from least to greatest when we do our domain. It's a very good question. All right, now, last but not least, example 3, identifying linear functions. Identifying linear functions. All right, now, one last time, we're going to go back to our coordinate graph. Okay. All right. So if I see a straight line going through the coordinate plane, I know that this is a linear function. I just need you to be able to identify a linear function. So straight line equals linear function. If it's a curved line, either curving and opening right or curving and opening left, we say that this is not a function at all. Why is it not a function? Because it violates my rule that for every input, there is exactly one output. Well, you see clearly here, I just kind of plotted the point on negative 2. Well, it's saying that if I put in negative 2 into this function, I can get a positive and a negative output. Well, that can't be. It's either one or the other. It can't be both. So this is not a function. This is not a function. All right, and then last but not least, we have the functions that open up or they open down. These are what we call nonlinear functions. We call them nonlinear functions because they're not a straight line, but they are still a function. Okay, so that's basically what you just need to know for your quiz and your test. You need to be able to identify a linear function. And that is it. That's everything you need to know for 7.8.